Welcome to the first in a series of 5 lessons, where I will discuss how to create an ArcGIS dataset within a plain AutoCAD drawing. I will be using the popular ArcGIS for AutoCAD plugin from Esri. I will present 5 different sessions to outline the 5 different methods I use to create ArcGIS datasets within AutoCAD drawings. First, I can use the feature class creation tools in ArcGIS for AutoCAD to organize the existing entities in my AutoCAD drawings and define the schema based on my existing CAD standards. Secondly, I connect to ArcGIS for AutoCAD feature services, where the schema is automatically generated for me by the ArcGIS feature service. In the third method, I export GIS data to an AutoCAD file from ArcGIS for desktop using geoprocessing tools and models. The fourth method is to import the schema from an existing AutoCAD drawing where ArcGIS schema has already been defined. The fifth method is to create an AutoCAD template file so that whenever I start a new drawing, the ArcGIS schema will already be defined and I can fill it up with content. Let's get started. In this first lesson, I will discuss building GIS data from scratch. I will organize my entities into local feature classes using the tools available to me in the free download from Esri, ArcGIS for AutoCAD. I will be using the 350 release running on top of AutoCAD 2014. In this lesson, I will demonstrate how to add an ArcGIS coordinate system to an AutoCAD drawing, organize existing entities into feature classes using my CAD standards, define and assign attributes to any CAD entity, create new GIS features, and use my smart GIS-enabled CAD drawings in Esri's ArcMap. In AutoCAD, I can draw entities using any coordinate system that I want. This drawing was already drafted according to the coordinates of a Kansas state plane. In ArcGIS for AutoCAD, I must identify the Esri coordinate system that I'm using in the drawing, and then draw in that real-world coordinate system. So I will simply select the coordinate system I'm using in this drawing. The Esri coordinate system definition is part of a larger schema definition which can originate from the same 5 sources I've mentioned in the introduction. I'm creating ArcGIS data from scratch, so in this session I will define my drawing's coordinate system by selecting it from a list of coordinate system definition files provided by Esri when I installed ArcGIS for AutoCAD. This drawing is pretty much completed, and I have prepared this drawing using my own CAD layering standards without regard for any ArcGIS data. I have since downloaded and installed the free ArcGIS for AutoCAD plugin from Esri. I interact with ArcGIS for AutoCAD primarily through this ribbon interface. I will immediately start defining GIS data using the new feature class button on the feature section of the ribbon. Here I give my new feature class a name and then define which AutoCAD entities should be considered members of my ArcGIS feature class. I use the CAD properties such as layer, line style, and color to identify the GIS feature class members. I use the existing CAD standards to define the definition of membership. I have now established that the ArcGIS centerline feature class is comprised of linear entities on the AutoCAD layer called CL. I can, at any time, define tabular attributes on these AutoCAD entities as part of the schema definition. In this case, I'm creating a string called status. Feature class selection tools allow me to interact with my CAD data as also being members of GIS feature classes. All of my existing centerline entities can hold my status attribute variable now. I can edit a single attribute of a single entity, or select many entities and change their values all at once using either the attribute editing dialog or the table viewer window. I define additional feature classes in this drawing by repeating the same steps. I use the new feature class tool, select the geometric feature class type, and then provide the AutoCAD layer name or other entity properties that define membership for my feature class. The definition of membership can and should be simple. The best relationship is a single AutoCAD layer should equal a single GIS layer, but it doesn't have to. For example here, next I want to define an annotation feature class based on the lot number text on a certain layer in my drawing. I repeat the steps to define the new feature class as I've done before. I specify a GIS layer name, the geometric type, then AutoCAD graphic properties, such as the layer. But in this case, there's more text on this layer than just the lot numbers that I want. There are other notes that I don't want to include. The text that I want on this AutoCAD layer is colored yellow, whereas the other text is green or bilayer or cyan. I can use this fact to isolate the lot numbers and define a slightly more complex definition query for my lot number feature class. By selecting color in addition to the layer, I can limit the membership to just the pieces of text that I want. I have successfully defined ArcGIS feature classes inside my AutoCAD drawing. When I save this drawing, the feature class definitions, the coordinate system definition, and all the attribute definitions and their values are stored in the single DWG file. I can save my work and continue to work on it tomorrow. Or, if I were to email this drawing to myself at home, I can pick up where I left off, since everything I created is inside this DWG file. To add new GIS features to this drawing, I just continue drafting as normal. Since I based the method of defining feature classes on my existing CAD standards, to create new GIS features, I just continue to draft as I normally do. And at the same time, I'm generating ArcGIS features inside this AutoCAD drawing. I can use any AutoCAD method and tools I want to continue drafting and building content. As long as the new entities qualify for feature class membership based on their AutoCAD layer or other AutoCAD entity properties, they will be recognized by ArcGIS as GIS features. How the new AutoCAD entities are created are up to me. Just as long as they qualify based on their AutoCAD properties, they are considered new GIS features. I'm finished with this AutoCAD drawing, and I want to show you what it looks like to an ArcGIS desktop user. Let's take a look at it in ArcMap. By default, when the ArcMap user opens up my AutoCAD drawing, they will get all of the contents of the drawing sorted into different GIS datasets based on the geometric type. By default, they'll see points, polylines, polygons, annotation, and multi-patch feature classes in the AutoCAD dataset. They will also see my feature class schema, which lets them deal with my drawing as more than just a bag of geometry. They can immediately use my attributed feature classes as map layers without further sorting. Here, the layers are being used in a geoprocessing tool. This one builds polygons out of a network of linear boundaries and also incorporates the attributes of the point feature class as labels to those new polygons. Using ArcGIS for AutoCAD to define feature classes directly in the AutoCAD file makes it easy for the ArcGIS professional using ArcMap to easily access the data inside the AutoCAD files without conversion. Let's review. First, I created a coordinate system definition in the file so the CAD file will line up with the rest of the world. I defined feature classes in my drawing based on my existing CAD standards. I created attributed features that store tabular information on my AutoCAD entities. I created new features in my drawing by simply drafting in AutoCAD like I normally do. I also saw how easy it was for ArcMap users to use my data. In the next session of the series, How to Create GIS Data in CAD, I will explore how to acquire and interact with ArcGIS data in my AutoCAD drawing that originates from ArcGIS Web Services.